now. Alright, so today is day 6 of our 100 days of data structures and algorithm. We are still in the first week, so it's not a lot going on. So I would like to go over everything I have solved so far and try to explain them all over again and see how well I do with explaining all these topics. I'm going to start with the first 2 days. Let me just pull it up here quickly. So we have day 3, day 2, day 4, day 5, all up here. Alright, so on our second day, the first day was basically on time complexity and space uh, analysis, time and space complexity. Let me just erase everything here. Okay, right. So that's a way now. I think I can focus on what is here. Let me see if my stream is going on well. Alright, great. Alright, it's really good right now. Yeah, it's working fine. I think there is an issue with the quality of my videos, but I'll see if I can find a way to fix that. Otherwise, for now, we just have to go with what I have. And so let's see. Merging sorted array, right? I'll still go over the problem again and explain and see how well I do with explaining this, because I actually understand this question now. And yeah, so I'll do that here. Just open this tab. Uh, I've already solved this question, but is there a way I can explain it in order for it to be easy to understand, right? Well, this is my solution here. If I submit this again, I've already solved it. You can see the check mark is there. It has been solved. In terms of memory, it did well. But in terms of time, it did just below average, right? But it's still good because the trade-off was asking us to, you know, the trade-off was in favor of space rather than time. All right. Yeah. So what does this problem so what's this problem about? So it's about two arrays that are in sorted order. So let me read it again. You are given two integers, arrays nums1 and nums2, sorted in non-decreasing order, and two integers m and n, right, representing the number of elements in nums1 and the number of elements in nums2 respectively. Merge nums1 and nums2 into a single sorted array in non-decreasing order. The final sorted array should not be returned by the function, but instead stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, right? Where the first m element denotes the element that should be merged, and the n and the last n elements are set to 0 and should be ignored. Okay, so for a problem like this, it's always good to identify what their you know what is being asked, right? So here the problem wants us to do two things, just one thing, sorry. The problem wants us to store to return to merge two arrays, right? So let me just put it this way here. I'll just paste it here. Okay, that's already there. So now let me take this down a little bit more. Okay, this is coming up nice. I'm just trying to make space, right? So I see properly what I'm doing. Anyways, let me just open that. I'll close this here. Ah, no way. Okay, so the problem says, we have these two array nums1 and nums2, and the problem wants us to merge both arrays, right? So first of all, they're asking us to merge both arrays. So we want to merge, nums1. I'll call the merge from x. So they want us to merge nums1 plus nums2, right? Nums2. Now, what do this m and n here represent? M represents the amount of elements in the array nums1 that should be merged in this x here, right? So even if nums1 currently nums1 has 1 2 3 4 5 6 elements in its array, but they only want us to merge 3, so we are going to work with just these 3, right? And then ignore the rest, right? We just have to ignore every other thing that is after the 3. So we only use 3 elements from the nums1 array, which is why we have this m here as our indicator. Now nums2 also works the same way. Nums2 is the second array that we are merging nums1 with, right? And we are also using 3 items from this nums2, which is denoted by n. So this doesn't necessarily mean that nums1 has to have 3 elements in the array. It could be more than this, right? As it has to be in sorted order, of course. So we could have 7 8, right, after this. But the question is still asking us to merge this amount of element in nums2 and this amount of element in nums1, right? So now that is the first thing we know the question is asking us, right? What's the second thing we would like to know? Well, the question says we are not returning anything, right? They are not asking us to return anything, but we need to store the merged form, right? This is no longer going to be x. This is not going to be a new array, right? We have to do this merging in place. So nums1, right? Nums1 has to accommodate everything, right? So we have to have every item from nums1, every m item from nums1. I'll just put m nums1 here like this. I'll just put it as a base. Oh, sorry. M nums1 plus n item from nums2 like this, right? And we have to do the merge in place, right? Now that's the second thing we know, right? So nums1 at the end of the day will have m amount of elements plus n amount of elements, which is 3 plus 3. So the length of nums1 at the end of the day will be 6. Every item that was after nums1 will be ignored, right? We don't have to worry about those ones. Okay. So how do we merge m item from nums1 to with n item from nums2 in a non-decreasing order? So they have to be from the smallest item to the biggest one. Well, in that case, we already know that nums1 will have a length of m elements of nums1 plus n elements from nums1. Or in other words, sorry, m plus n, right? So that would be the length of nums1. So we'll say nums1 would look something like this. Nums1 at the end of the day will be ready to accommodate 6 elements. So I'll put 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, right? So 6 elements, right? And these are not just elements, all the elements in nums1 or all the elements in nums2. These elements are still based on certain factors, which is m here and n here, right? So how do we merge these two arrays? Now we already know what to do, right? We already have some few details. Well, to do that, since we are merging everything from nums2 into nums1, right, we have to run a loop, which is the size of the items, the amount of item that we are merging from nums2 here, right? Nums2 could have been n of nums2 could have been 2, right? It doesn't matter. We are not working with the length of this array, but we are working with this value here, which is n. So we are going to run a loop which is going to take as long as the amount of elements that we want to merge from nums2, right? So here's what we do. So we'll start our loop. Our loop has to we can start in either way. It doesn't matter. We can start from front, we can start from the back, right? But I'll prefer starting from the back. So I'll say the value of n is now 3, right? So we'll start from the back. So that would be n minus 1, right? Because we want to merge 3 items from this array, and in computer language we don't use these values like this. We don't use them straightforward. We don't have an element at the third index in this array here. Although we have 3 items in this array, there is no item that appears at this position here, because computers start reading from 0. So we have 0, 1 and 2. So in order for us to start with the last item, we have to do n minus 1, which is 2, right? So we compare the last element from the second array with the last element, right, from the first array, based on how many item we want to merge in the first array, which is m here, sorry. So again, we'll do m minus 1, right? So that will be the last item in this index, in this array here. So we'll do n m minus 1. So this will be equal to 2, right? So we have 2 here. So we compare. We'll put m minus 1 here. I'll call this x1, right? x1 is equal to m minus 1, and x2 is equal to n minus 1. So we'll compare the item at x1 with the item. Let me erase this. Oh, Christ. Okay, I'll give up. We'll compare it with the item at x2 here. So this is x2. Now the item at s2, right, is the item at s2 bigger than the item at s1? So that's basically what we are going to do each time. So we'll compare the last item with the last item that is here. So x1 versus s2, which one is the bigger one? Obviously s2 is bigger, so the value at s2 is 6, so we'll put 6 here, right? And then we'll move s2 by 1, because we have to shift it, right? We have to shift it towards 0. We want it to stop at the first index here, right? So in order for us to move it towards the front, we need to reduce it by 1. So when we reduce it by 1, s2 will be at this position here. So is the item at s2. Also, we don't need to move this one yet, because we still don't know if this this doesn't still have a place in this nums 1 here, so s1 will still remain at this position here, which is 3, right? So s2 is now at 5. Is 3 bigger than 5? No, of course 5 is bigger than 2, so the value of s2 will come in here. So this will be 5, and we'll move s2 by 1 again. So s2 is now at position 2, right? Is 2 bigger than 3, which is x1 here? No, 2 is not bigger than 3, so we put 3 here and we move x1 by 1, right? S1 is now equal to, is now 2, right? Is 2 equal to 2? Yes, I mean, is 2 bigger than 2? No, 2 and 2 are equal. So what we do here is basically put both of them here and move them by 1 each, right? So we'll move this one by 1, right? When we move it by 1, basically we stop the loop because x is already at 0 here, so we don't have to run any check at this point again. All we need to do is to move x1 by 1, right? S1 will now be at this position, and we don't even need to compare with any value in s2 because we've already reached the end of s2, and then we just put x1 here, which is 1. The value here is 1. So this is how you solve the the two-sum problem. Oh, sorry, merge sorted array problem. Sorry, merge sorted array problem. All right, that is you know number 1. We're done with number 1. So merge sorted array is finally engraved in my brain. Now I know how to solve this question anytime I say it. I think I solved a two-sum problem, right? Two-sum problem. Two-sum problem on day 2. Yes, I did a two-sum problem on day 2, and there was contains duplicates problem as well. So two-sum problem here, right? So let's read that one too, and we'll try to explain how we would solve it. Okay, so I've already solved this question. It's not hard, right? It is actually very easy. So what this question is asking is, given an array of integers nums and an integer target, right? So we are given an array of integers and a target. Return indexes of two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Well, this is also crucial to understand, right? You can return the answer in any order, right? So let's understand what this question really is. So I'll come back to my board here. Let me erase everything I have here, right? And go back here. And so we already know we are being given two inputs, right? One is the nums, which is an array of integers, and the second is a target, right? So they want us to return two numbers from the nums, which is the array of integers, such that when added up, they such that they add up to the target, right? So when you make the addition of those two numbers, then when you sum those two numbers up, you get the target. So let's use this example here. We have nums, which is equal to this target here. I'll put this one here. Where is the value? Okay, it's here. There's a very important part of this question that I think it is crucial for anyone solving it to understand. Although it's an easy question, right? But you can easily miss it, right? So which is this part here. You said you may assume that each input would have exactly one solution, right? So the array is always going to what, to have two items that will always add up to the target. So there is no edge case to introduce your code in order for you to return false or any other value when you don't find any two items that add up to the target, right? There's always going to be that case where two items at specific position will add up to the target. Now, and you may not use the same element twice. So imagine the case where you have elements like this. Let me just come here, right? You have elements that will add up to the target here. In this case, let's assume the target was 14 here, right? 7 plus 7 is what? Is 14. So what the question is saying that we shouldn't use the same element twice, right? Don't use the same element twice to get the target. You must always use two different elements, which means those elements will always be in two different positions, right? Now, what is the value the problem wants us to return, right? They want us to return an array of indexes, right? So return indices of the two numbers such that they add up to the target. So in this case right now, we know 2 plus 7 is equal to 9. But what is the position of 2 in this nums here? The position of 2 in this num is 0, and the position of 7 is 1, right? Computers always start reading from 0, so we have to make our counts from 0, right? We can't do 1, 2, 3, 4, right? Although 4 is the length of this array, but for an item at index 4 is out of bound. We don't have anything there, so we always start from 0, right? And we have 1, we have 2, and we have 3. Now, what the question says we should return is an array of two elements, right? Of the indices of two elements, such that when they add them up, when they are summed up, it is equal to the target here. So we know 2 plus 7 is 9. So at what position is 2? 2 is at 0 and 7 is at 1. So we have 0, 1 like this, right? Which is all we need to do, right? That is literally everything. This is the solution, right? But now there's a catch, right? Well, how exactly do we determine this? First of all, the first thing you might think, okay, we can start a loop, right? We can start, I'll start with a first loop. I'll start with a loop like this. I'll call this loop 1, right? Loop of I, right? Where I is equal to 0. So I'm pointing at the first element in this array. Now, I'll do nums like this, nums at at I, right? This is my first item, right? Then I will run another loop inside within this loop, right, to target each element. So I will do 2 plus 7, right? And then if 2 plus 7 is not doesn't add up to the target, then I'll continue with the second one. I'll do 2 plus 11, then 2 plus 15, right? If the inner loop is done, when the inner loop is done and I don't return any number, then in the next iteration I will now be at this position here. Then I will do the same thing. I will do so our nums at I will now become 7. So I will do 11 plus 7 and 15 plus 7. In the case where I don't find any other answer, I'll move I to the next position. Then I'll start with J again, right? And you can see every time we run the inner loop is always at a position of I minus 1, right? So we are putting a pointer somewhere, right? So the inner loop will look something like this. We'll have for, let me just put here, for j, you know, j will now be equal to what? J will be equal to I minus 1. So I minus 1 in terms of range, right? So we want to start the range for I minus 1. So I will do from j in range. No, we are using indexes. So yeah, so from j in range, right? In range, now we want to do I minus 1. So that we, sorry, I plus 1. I plus 1. So that we are the second index here. We choose the second number. So we go I plus 1, right? And we stop at the end of this array here, which is len minus 1, len minus 1. Then we can now compare each item. We'll say if nums at I is equal to, you know, the nums at j, right? Then we can return, you know, I and j, right? We know I and j already represent the indexes, right? So this is, you know, a first solution, right? We'll continue looping until we find a match. But in terms of, you know, in terms of time, right, this isn't effective because we are always, you know, concerned about the time. At least the question is asking us to take time complexity into consideration. The time complexity for an operation such as this one is always in quadratic time, right? So it is O of n squared. So this, I think the squared is outside. Yeah. So this here is not an effective solution. Although in space complexity, it increases with the input, right? And what is the input here? The input is the input is nums. So, but nums alone, right, is being checked in both of these loops. So we are checking an item at nums I and an item at nums j. And these two, you know, indicators here are sorry. So this I here and then this j here. So both indicators here are every item in this array as well. So even in terms of space complexity, this is still in quadratic time, right? In quadratic space, right? Sorry, it's not in quadratic space, but in linear space, because this array does not increase, right? But in terms of time, it's actually increasing. This operation has to run so many times. So this operation here, or this one here, although this doesn't run, sorry, this if statement here will run for every time we reach this loop and for every time we start the bigger loop as well. So this is not an effective solution in terms of space complexity, and even in terms of time complexity. In terms of time complexity first, then, you know, also in terms of space complexity. Although we're always worried about time, right? Is the time complexity, unless the question specifies that we check for space complexity. Okay, so here's what I'm going to do. First of all, I'm just going to use, you know, simple, you know, algebra for this problem. I'll say our target is 9. So let's call our target T, right? What is T? T is, you know, any two items from this array, right? The sum of any two items. So I'll say num x plus num y, right? Now, what is the value of T? T is 9. What is the value of num x? Well, we already know num x can be anything in this array, right? It can be anything. It could be 2, 1, 7, 11, 15. It could be anything. So we can, you know, randomly select any item for num x, right? So we can say num x now in this case will be equal to the first item in the array, so it is 2, right? And now we can look for y, right? We can look for y. So 2 plus num y will give us this target here. Now what is num y, right? Num y is going to be what? Num y is equal to the target minus any item here, right? Any element in this array here, but I'll call this num x. So each time we look into this array, right, we want to make sure that we check the item at this particular position here. We minus it from 9, right? And then that will be the next value that we have to find in the array. So if we look for the first time, we can say, okay, since we are looking for num 2, right, then we'll say 9 minus 2, right? What is 9 minus 2? 9 minus 2 is 7, right? So 7, what is the position of 7 in this array here? Okay, we know that the position of 7 is at the first index here, so it's going to be 1, right? And then what number did we use to make this operation? 2. What is the position of 2 in this array? 2 is at position 0, so our answer will be this 0 1, right? This is our answer. Now the main question now is, how do we find, right, the next number inside the array? I mean, how do we find our num y in the array? Well, that is quite straightforward. What we need to do is we need to create another version of our nums, and then have it matched against indexes. So we'll do something like this. We'll say I'll call this a map, right? Obviously I was going to call it a map, so I'll create a map and I'll say what is the index of 2 here? Okay, 2 is at index 0, 7 is at index 1, and let me do this. Oh Christ. And 11 is at index 2, 15 is at index 3, and we'll do something like this, right? So this is our map. Now we'll have to run a loop, right? So we need to run a loop, and each time we are at a certain position and perform our operation, num y, right? I'll just call it ny. Ny will always have to be a value that is inside this map here, right? So if we do first of all 9 minus 2, right? 9 minus 2 is equal to 7, because we start from the beginning, right? What's the item at position 0, right? The item at position 0 is 2, so we do 9 minus 2. What is 9 minus 2? 9 minus 2 is 7. Is 7 in this map? Yes, 7 is in this map. And what is the value of 7 here? The value of 7 is 1, so the final result will be 0 and 1, like this, because we know that our loop started from 0 up to the last item here. So but fortunately for us, we found the the item 7, right, in our map in the first iteration, which is good, right? What if we had something like this? We had 3, 1 and 3 here, right? And the target t is equal to 6, right? So here's what we are going to do. We are going to we create a map of our we create a map of this array here. We'll call it 3, 0, 1, 2 and 3, 2. 1 1, sorry. Christ. 1 1. Sorry, 1 1 1 2 3 1, like this. 3 2. Jesus. 3 2. So what we are going to do next is start a loop, right? I'll call this I. I here is equal to 0, right? So when we are running our loop, I will start from 0. I will become I will become 1. I will become 2 as the as the loop progresses, right? So what is the item at 0? The item at 0 is 3, right? So we do the target, right? Target, we are looking for ny, right? The second item in the in this array, when added up, will give us 7, which is our target. So I'll call this ny is equal to 7 minus nums at I, right? Or 0 here. So minus 3, this will be equal to 3, right? Is 3 in this map dictionary that we created? Is 3 in this map? Yes, we'll look into this map. 3 is here. Now what is the value of 3 in this map here? Well, the value of 3 here is 0, right? So but because 0 is the same value as I here, we can return 0 and I, right? So we need to ignore 0 here. This is the only edge case that we need to put into consideration. We don't want to return an item as 0 0 because we found a match. We don't want it that way, right? So we need to look at the map. We need to look into the map, find an item that is that is the result of this operation and whose index is not the same as I here in this current iteration, right? So when we say, okay, look into this map, find a number when such that when I subtract the current item in the iteration from the target, I get that value. Yes, we found 3 here, but does 3 beat the criteria? Is 3's index the same as the current index in the iteration? Yes, we skip 3 and then we check if there is another item. Yes, there is another item. What is its index? Is 2, right? So our answer will basically be 0 and 2. This is the final result. So this is how you you solve a question like this. Here is my Python solution exactly as I explained it, which is the 2-sum solution, right? So the next one is I need to organize my sheets very well. I just did 2-sum now, so I need to put that here. I'll put it later and then upload it in my description. So we have DSA. So did I do merge sorted array? Yes, that was the first thing I did. So on day 4 we did string manipulation and valid palindrome, which was a very, very, very awesome experience. So the solution for this was quite coming. I'm just making sure my stream is going on so that it doesn't. Let me close all these tabs so that they don't interrupt me. Okay. Right, so valid palindrome. This is a very good question and it has a little bit of trick to it, but it's still one of it gave me that feeling, right? That eureka moment where you finally got an answer. So I'll walk you through my solution again, which I think, um, you know, was the best possible way I could have solved this solution, this problem. All right. Huh. I can see that on LeetCode, right? There's this Spotify logo on it, so which means Spotify has asked the question before, right? Is it 125? Let's be sure that it's 125. Yeah, it's valid palindrome 125. So a palindrome is a string or a word that can be, read in both direction the same way, right? So let's read this question. If a phrase is a okay, it's not just a word or a string, it's just a phrase, right? It could be a phrase or anything. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphabetic letters, it reads the same forward and backwards, right? Alphanumeric characters include letters and numbers, right? Giving a string, return true if it is a palindrome or false otherwise. Okay, so giving a string, return true if it is a palindrome or false if it is not. And what is a palindrome again? A palindrome is a phrase if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Right, here's an example, right? We have S is equal to S denotes a string, right? It represents a string or a phrase in this case. So a man, a plan with commas in this phrase, a man, a plan, a canal, Panama, right? A man, a plan. So when you um remove or when you strip away all the non-alphabetic or you know characters that are not alphanumeric, that are neither a letter or a number, right? When you strip everything away and you convert everything into lowercase letters, you get a man, a plan, a canal, Panama here like this, right? Now, when you read this backwards, right, it also says the same thing. A man, when you move this to this position, every other thing to the other side, it will still read the same way. It will still read a man, a plan, a canal, Panama. So this is a valid palindrome. Now, is this second one a palindrome? Look at this. You have race a car. Race a car. So here is, the only thing that bugged it a little, because when you see race a car like this, you can't read it the same way backward. You read raka ika. So it's not the same. It doesn't read the same backward and forward, right? An empty string is a valid palindrome because there is nothing inside, right? What are you comparing it with? Nothing. So it is a valid palindrome, right? So so how do we solve a question like this? I will use my solution again. I'm going to stick with that solution because it is the best I understand, and I also came up with it, so I will never forget it. But as time goes, I will go and read other people's solution and see how I can improve on mine, right? So yeah, let's start with the first one. Let's choose an easier word that is a palindrome. Here's what I did yesterday. So I said, okay, if we had a word like this, R-A-R, right? Well, this is a valid palindrome because if I were to write it backwards, so here's what I did. I denoted each one of these with a base, right? So since this one is at position 0, I'll put O here, 1 here, and 2 here, right? Now reading this backward will also read this way. So I'll have my R, which is at base 2. Sorry, this is normal, not normal basis, which has, I'll just call it R2. A has a base 1, and then we have another R here, which is our first R, which is equal to 0, right? Now this is a valid palindrome because we can still read Ra, backwards, even though we switch the position, and we can also read Ra forward, even though it is, this is our original string, right? Or this is our original phrase. So it's read both forward and backwards the same way, even though we are switching the positions. Right now, here's what I did. I said I'll create a map because I think map has helped me a lot. So I kind of visualized these things and quickly recognized that, okay, this is a search for a certain value somewhere. So what are we searching for? We are basically searching for, items at specific indexes, right? So let's say when I reverse this string, right? When I reverse this string into this direction, right? It should still read the same way. But what factor makes it read the same way? Well, if we look at the original string, right? The character at this position should be the same as the character in our reversed string, right? Which is R, and then we have R here as well. So in our original string, what is the second character that we have in that string? We have A. In our reverse string, we also have A here, we have R here, and we also have R here, which makes it a valid palindrome. That is all. Now here's what I came up with, right? So since this is the way we want to validate a palindrome, I need to map each item at specific indexes. So I'll create a map, but this time around I'm not creating the key of the map as the value in the string, because if I had R here equal to 0 and A equal to 1, I can still have another R in this map again, because in terms of code this will not be accepted. You can't have duplicate keys in a map, right? So you need to have unique elements that point to a specific value. The value can be the same, but the key cannot be the same, right? So here's what I came up with. So I said, okay, I will do indexes versus the actual value. So we'll have 0, right? Because the indexes are increasing, right? You can see 0, 1, and 2. So I have 0 point at R, another 1 point at what? A. We have A here, and then 2 pointing at R, like this, right? This solves 50% of the problem, right? Because we have a map here that we can look into and find values at specific positions. Now, a reverse of a string is basically reading the string from backwards, even if we keep the string the same way, right? It simply means we are reading from here towards this place. So which means R will be the first R2 will be the first element we looked at, and then A will be the second one, and the last one will be R, right? R0, A1, R2, which is what I represented here. So we'll have R2 as our first element, A1 as our second, and R0 as our last element. Now, how do we get the last element? Well, if we loop through this string here backwards, right? If we start from the length of this string minus 1, we'll easily get the last element here, which is R2, right? Now, let's say J here is the length of the string minus 1. So we are starting from the back, right? Let me use a different color. I'll say J is equal to um what's the length of this string? It is 3. So the last item in this string will be 3 minus 1, which is 2, right? So when j is 2, right, what is the value of the item here in this string? Well, the value is going to be r0, right? What is the value of r0 in this string here? Let me properly represent it. This will be r0, ra1, and r2. Okay, what is the value of r0 in our map here? Well, the value of r0 is going to be 0, right? But what are we comparing? What are we using as our, like source of truth, right? So I'm at the last item in the or I'm at the first item in the reverse string, right? But what is, because we know that there is no way we won't see this item, right? Even though we are starting from the last one, there's no way we'll see this item in this string. But the last one here is 2, right? The last one here is 2. But what can we compare this value with? What can we, how can we, if we say, okay, we want to look at r2, right, in this string? Yes, of course, r2 is at position 2, right? This doesn't really uh doesn't really uh proves prove the fact that r2 is actually going to be the last item in the array, right? We need a specific item that actually gets the position correctly. So what I did is I set a pointer, right? I set the pointer to be equal to 0, right? Now this pointer will help me, right? I will increase this pointer in every iteration. So in my first iteration, while j is equal to 2, right? While j is equal to 2, I will look into this array, because I can't say map at r2 or r's. Yeah, we are starting from r2, right? I can't say map at r2 right now. This is invalid because the key of our map is not r2, it's instead 2 or 1 or 0, right? So I'm going to use the value of j to look into the map and find that particular value here, right? So if I say j at 2, right, j at 2 has to be r2, right? But how do we get r2 here? Because j at 2 in the inverse string is r2 already, but we can't do j map at r2. We can only do map at j, which is the value of j. So here's what I'm going to do. I'll just say, okay, map at j, right, will give me a certain value, but because I'm at position 2, right, I'll just do, let me erase this. Because I'm at position 2, I'll just do map at 2. The value of j is 2, so I'll do 2, right? What is the value at when the key in the map is equal to 2? Well, the value is r2, right? So this is r2 here, and then we are already looking into r2 here, the last item in the array. Let me go back here. I'm not reversing this trick, so I'll just start from here. So j is at this position, right? When the value of j here, right, so we put map here, so the value of this map here, right, has to be the same as r2, right, at this position. So what is this value here? It is r2, and our correct last item here is r2 here. So already we found a match, so this passes the first case. Then we increment, we loop again, we continue the loop, and then we find the next item. Now what is the next item? The next value of j will be at this position, so j will be equal to 1. What is the value of j at position 1? Inside this map here, the value of j at position 1 is going to be a1. Sorry, I didn't put it here. So it's going to be a1. And what is the value of the item in this string at position j, right, that value is going to be a1 as well, and so on, right? We are going to increase it like that. But there is also one tiny problem with this solution, which is why I was talking about a pointer here, right? Why do we need a pointer? Let me show you something. Here's why we need a pointer, right? We can't directly compare with the indexes, because when you are looping backwards, right, this value change, especially in the case where we are checking for alphanumeric values, right? J is increasing, J won't stop for us, right? But the best solution is to have a pointer that increments every time we find a number in the um in the in the map, which is also an alphanumeric character. Let me explain again. Say for instance we have a string like this. Let's say arrow, right, comma a comma r, right? Now when we are looping backwards, right, j will increase with every, will decrease with every value. J will not skip any value because it is not alphanumeric. We are going through the string all over again. So here is why we need a pointer. The pointer will only increment, right? This pointer will only increment when we find a number that is alphanumeric and also is inside this string here, right, inside our map. So here is what happens. So pointer will be at 0, right, and j will be at position let's say 1 2 3 4 5 6. So j is equal to 5. Let's use this. Let me clear the screen and start over again. Let me use a typical, proper example. Let's say we have the string r comma a comma r, right? First of all, how do we create the map for this? It's going to be the same process. We still need a pointer here. Otherwise, when we are creating a map directly, we'll have something like this. Sorry, I said I will use the indexes, right? So let's say we are here, right? What's the length of this? This is 6, right? So the value of I will be 6 minus 1, which is 5, right? So r is at position 5, so we have 5 equal to equal to r like this. How am I going? So let me just do it like this, right? R, right? That is r. And then when our string, when I is reduced by 1, we are at this position here, right? So I will be equal to 4 at this point. But because 4 is not an alphanumeric character, we want to move I by 1 again. So we move it to the left. I becomes 3, right? But if we are creating our map this way, then I here, right? So 3 will be the next value we insert in our map because we already skipped this one here. And then 3 will be pointed at A, and so on. You can still do it this other way, right? Let's say you start from the beginning, right? I will represent it again. R, A, R. We have comma, comma, in between them. The first item here is at position I, right? Already we know I is equal to 0, which is the first item in this string, right? The second, so when we create a map for this value, we'll have something like this. So at 0 we have R, which works fine. But the second item in this string is comma, right? Is comma an alphanumeric value? Already I will be equal to 1 here, right? This is I. Is comma an alphanumeric value? No, comma is not an alphanumeric value. So we skip comma and increase I by 1 to point it at the next number, right? So already I here will be equal to 2. Now, is the character at 2 an alphanumeric value? Let's call this our string S, right? Is the character at the position 2 in this string s here, an alphanumeric value. Yes, if it's an alphanumeric value, we'll put it here. So we'll have I equal to 2 versus what? Versus a, right? So 2 versus a, and then we'll increment this again. We'll say, okay, the next item is a comma, and I will be what? I will be 3 at that point. Is I alphanumeric? No, we skip and we move to the next one. I is equal to 4, and then this is alphanumeric indeed. So then we now put 4 here and R behind it. Now you can see this is not really in a very good order that we can easily predict, right? When we are looking backwards, so let me represent this again by X, and we have R comma A comma R, right? When we are looking from the back, right? When we are looping backwards, now I will be equal to 5. Now we have an item at this position here, 5. But is there 5 in this string here? No, already if we don't find any key that is equal to 5, then we can conclude that this loop is not a valid palindrome, right? But saying it like this, that is wrong, right? This string is still a palindrome. When we strip off every comma and every other character, spaces and everything, this string still reads the same way backward, right? So here's what we are going to do. Instead of using the value of I to look inside this loop, right, we need to have a pointer, right? A pointer that can do a good job for us, right? The pointer, we can have a pointer here, right? I'll call this pointer 0. Now our condition is requiring us to not our condition per se. If a palindrome is a string that reads both ways, right? So you can read it the same, that reads the same both in both directions. You can read it one way forward, the same way backwards, right? So which means the position of elements, right? The position of the elements can change, but the value remains the same. So if I'm looking at the last item in the string, it should also be the same as the first item in the original string, right? Or in the same string as well. So it doesn't really matter, right? But here I have 5. If I'm looking backwards, I have 5, but there is no 5 in this string here, right? As key of this map here, there is no 5. So what is the best way to do this, right? So the best way to do this is to have a pointer. That pointer will be at 0, right? So every time we find a value, right, that is actually alphanumeric, then we can increment the value of the pointer, right? Let me show you how to do that. So R is at I, right? I is equal to 5, right? But we are not going to use the value of I. We are going to use 0. We start the pointer with 0. Now, is a string at index I, which is equal to 5, right? In this, here's how we are going to do it. We are going to use our pointer, right? So I'll call the pointer P, right? This is too long. So we'll look into the map, right, and use the pointer. Pointer is P, right? Is any key at P which is equal to 5, right? Is any item at P, right? P is equal to 0 at first when I is 5, right? P is equal to 0. So is any value here, right, that is equal to this string here, this string at 5. So I'll put S at I. Let me do this. S at I, right? I is equal to 5. If it is, then good, we continue the loop. Then we increment p by 1 only when we find an alphanumeric character. So the next time I is equal to 4, right, we are not going to compare it with 4, right? We are not going to compare it with 4 because this is not alphanumeric, right? Already we would have increased, we would have you know, we would have we still kept I this will be 1, sorry. So after finding this solution where p matches, we will increase p by 1. So p will be increased by 1, and then we'll look in the loop again. The next time we look inside this loop, right, we'll find another non-alphanumeric value, but we don't want to check that with any value here. So we increase p here, I here again, or we decrease I here again. I will be equal to 3. Sorry, I will be equal to 2 here, right? Because it goes it goes from 5, 4. Oh, okay. So this will be 3. This will be 3. So I will be equal to 3, right? Now, yes, although we found I at 3, the value of p here at this point will be 1, right? It's going to be 1, which means we can't compare it with any value here. So also, this also means that p has to be increasing regardless of regardless of the fact that we found an alphanumeric value here or not, right? But that is also not safe, right? So it means we need to wait. If this was at position, let me just, so we said, I can't erase this now, let me go. I'll say 5, I is 5 here, I is 4 here. When I is a comma, it is 4, which is pointed to. When I is equal to 3, when I is a, I is equal to 3. When I is point to this alphanumeric value, it will be 2. When I points to this one here, it will be, what am I doing? So we are starting from, sorry, we are starting from 4, right? Is it 4? We start from R. What's this? 1, 2, 3, 4, 5. Okay, so we start from 5. It points to this one. 4 points to that. 3 points to this. 2 points to this, and 1 points to that one. What did I count this well? 1, 2, 3, 4, 5. Sorry, we start from 4. Christ, we start from 4, right? We start from 4. Then we have 3. We have 2 here. We have 1. Hopefully this doesn't hurt your eyes as you're looking at them. So yeah, these are the values. So at each time we increment we decrease I, we need to increment the pointer, right, to keep track of the current alphanumeric value, right? So if pointer is increasing each time we decrease I, that means at this point pointer will be equal to 0. Let me represent pointer with a different color. I'll use this one. At this point pointer will be equal to 0. At this point pointer will be equal to 1, right, when I is a comma. But when I becomes an alphanumeric value again, pointer is going to be equal to what? Pointer is going to be equal to 2. Now, is there 2 in our map here? Of course there is 2. What is the value of 2? The value of 2 is A. And what is the value of S at I in this current iteration? It is A as well. So we are already on the good side. So we can still increment the pointer regardless whether the string is the character is alphanumeric or whether the character is alphanumeric or not, right? We can still increment it. Otherwise, if we want to create a proper map, we can have a second pointer for a proper key for the map where it increases by it increases in um in a normal order, right? In sequential order. So we'll have like something like 0, 1, and 2. Then we'll have a separate pointer for this, and a separate pointer for the second one here, which is what I did in my solution. But I'm just realizing now that this pointer here can still work for both forward and backward strings to make it a valid palindrome. So in the case where I becomes where p, the pointer is equal to 3, right, which is at this comma here, we don't want to compare because this is not alphanumeric character. Then we'll ask, we'll increase p by 1. P will be equal to 4 at this point, right? Is there 4? Because we always, this is the condition that we use to perform these checks, right? So is there any item where p, any item in the map that is equal to 4 when p is equal to 4? Yes, we have r here. Now what is the value of s at I when I is equal to 0, right? I will be equal to 4 here, so this will work for, so this means rar, despite having, when we strip off every non-alphanumeric character, is still a valid palindrome. Now, what is not a valid palindrome? Let's say a word like bar, right? I still used this yesterday, bar. So I'm just going to clear the screen and use that for my explanation. I'll write bar, right? Create a map for bar. So we'll start from 0, right? We'll go 0, despite not having commas, we'll still use it that way. So we'll go 0, right? We'll check what is the value at 0. The value at 0 is b. What's the value at a? The value at a is 1. So the value at 1, sorry, is a. The value at 2 would be r, like this, right? So this is our map that we created from this bar. Now we want to check if it's a palindrome, so that means it has to be read the same way backward. But already we know that this is not a palindrome. Rab is not the same as bar, right? So if we check the last item in the string, right, the last item, if we look backwards, right, if we look backwards, we want to start from the last item here. So let's say this is the length minus 1. I'll represent length minus 1 by j. So this will be 3. The length of this string here is 3. So minus 1 will be 2. So we ask if the item at position j, right, when j is equal to 2, right? So is there 2 sorry, so when j is equal to 2, right, so we'll still have our pointer as well, because we don't want to use we don't want to use these indexes here, because it will always fail, right? It will just return true. So here is why we need to use a pointer. So we have to put our pointer at 0. Let me represent the pointer by a different color. So I'll say pointer p at 0, right? So r here, so the value when the pointer is equal to 0 in this map here, let's call this map m. So m at p equal to 0 is what? M at p equal to 0 is b, but the condition says that m at p equal to 0 is supposed to be r for it to be a valid palindrome, at least for it to start looking like a valid palindrome. So if this p here gives us b, then it doesn't match this, let me call this s at j here, then this is not a valid palindrome, and we return false, right? We return false here, like this. So here, this is our solution for the valid palindrome question. Right, I think that's good. That's good for now. Let me see, let me check if my stream is still going on. Yes, it is, it's going on still. but it's quite behind. Uh, it's not in sync. It is not in sync. Well. I see. That's what's happening. Okay, it's actually good. I'm the one seeing something else. Okay, yeah. So that is our valid palindrome question. We don't need two pointers. One pointer is okay, or we can call it a tracker. Because not to confuse, we are still learning. So I'm still learning about these different data structures and algorithm concepts. I've not done pointers yet, but this is already looking like pointers. So yeah, it's also valid, right? So now let's solve a different question. Um, so let's say reverse string, right? I hope this is still an easy question. There is no rush, right? There is no rush. At least getting a solid foundation really counts. So yeah, I've never solved this question before, but I really believe it's going to be easy. Um, because these are all easy questions that I asked ChatGPT to get me. Right. Okay, here we are. So, okay. Write a function that reverses a string. That reverses a string. The input string is given as an array of characters. Okay. You must do this by modifying the input array in place with O of 1 extra memory, right? We're already. Oh, okay. Sorry. My table is just really shaky. With O of 1 extra memory. So here's what's happening. So we have an input like this. I'll just copy this. So we want to reverse this string in place. Use control. Okay. Oh, I see. Control Shift V. All right. Let's see. Oh, nice. Control Shift V works. Fine. Let's delete that. Let's delete that as well. Okay. We are good now. Let's go to the side and read this question very well. It's an easy topic, so and it works with pointers. So we'll try and I'll try and come up with a solution for this, but yeah, let's give it a go. I've not solved this question before. Reversing in place, right? What does this mean, really? So, in place algorithm, redirect here for execute, blah blah blah. In computer science, let me just zoom this in a little for you guys to see. Right. In computer science, an in-place algorithm is an algorithm that operates directly on the input data structure without requiring extra space proportional to the input size. In other words, it modifies the input in place without creating separate copy of the data structure. An algorithm which is not in place sometimes is called not in place or out of place. Okay, that's enough information. Well, they want us to simply, you see, as this S is equal to hello, right? It's an array of single strings. They want us to reverse it, right, in the same place, right, in the same position. So how do we do that? Well, let's say this we are not. I mean, I like to think of it this way. For me to do, an in place operation, right? Let's say we have these characters. I will just picture it as items that I have, in front of me, that are placed in a shelf, right? So to move them in a single place without actually placing them somewhere else, right? Then I would just have to carry it with my left hand, put it here. I will just, pick both and then switch, move to the one, switch, move to the other one, switch, and move and switch and switch and switch and so on. So this is how I'm going to do it, right? Um, Again, this question is easy. That is why, I'm able to. Anyways, it's all good. So here's what I'm going to do, right? I have hello like this. What I'm going to do is I'll just, oh crikey, sorry. I'll call this I for input, and I have HELLO, hello. Okay, so here's what I'm going to do. I'll call this my left hand, right, and my right hand here, right, my left and my right hand. So what I said I would do is I will swap, my left hand with my right hand. Any item I have in my left hand, I'll move it to my right hand, and any item I have in my right hand, I'll move it to my left hand, and so on until I reach a point where I can't move any item, like that again. So here's what I'm going to do. I'm just going to say the item here, still it's going to still be, in this input I here. So we are doing it in place, right? So here's what I'm going to do. I'll just say the item at this place will come here, right? And this one will go back here. But what is really this my right hand here? My right hand here is just the index of the last item in the array. So what is the length of this array? Is 1 2 3 4 5. So this is 4. My right hand will be at 4, and my left hand will be at 0, right? So I will move this to here and move that to here. Then while when I'm done with that transaction, I will move my left hand to here and my right hand to this place, right? Then I'll still do the same swap again. Left hand here, right hand there, right? Now there is an edge case here. When do I know to stop, right? Well, basically I know that I'm in, reducing my left hand by by a certain amount of elements. So I'm reducing it by 1. So in this case here, let me properly represent this by different colors, right? I'll say my left hand is blue, right? LN is blue, and then RN is green. So when I move this green here, right, to this position here, I want to move this one to that other position here. So in my first iteration, I'll have 0 E L L and then H, right? This will be my first iteration, the result of my first iteration. Then next time I'm moving this, right, to this position here, sorry, no longer there, but here where my right hand is currently. And then the item at my right, I'm using a different color again. Sorry, the item at my right hand here, so I'm just going to do it this way. So Rn will be here now, right? So I'll move Rn to this place, and then Ln will be here. I'll move Ln to the position of Rn. Now, when do I know when to stop? Well, basically, Rn and Ln would have had the same value, right? So I would know that this is where I need to stop at. So I will not make any operation here. L will still remain there. So at the end of the day, I'll have 0 E a 0. Sorry, we have already moved here. So 0 L L E H. So here is the reverse of this string here. Now let's code it up. I'll see how well I do with this one. So guess what I'm going to do? I'm just going to come here, right? And I'll just see, okay, here's what I need to do. I'll create a new folder called reverse string. It's already 11:20. After this question, I'm done. Christ. I started late today, which is really, really bad. Very bad. So reverse string, reverse dash string. I think I should be indexing the problems with their number. Reverse string, LeetCode 344. I'll put LC 344 because I'm not going to solve only LeetCode problems, right? I can solve problems from anywhere that I want. Oh, the timer stopped. I forgot to increase it. Let's give us another 10 minutes. 10 minutes max. I promise. 10 minutes, we are done. Okay? Because the solution is quite clear now. 10 minutes, I'm done in 10 minutes. Let's go. Right. So I'll copy this and paste it here. And just import the type for lists. From typing import list. Okay, I don't know why. I think I need to do some configuration for all this indentation. It's really annoying. I have to give so much space. No, what? One is already enough. Do not return anything, just modify in place. Okay, we are not returning anything. Right. So we said I said we'll start with the first one. So let me go back to my board and see how we are going to do it. So I said we'll have a right and left hand. Yes, that at least I remember. So I'll have right and left hand and decrease them each time. And the only case where we will stop the loop is when we are at this point here where the left hand and the right hand clash, right? They are now equal to each other. So hey, oh my god, I'm sweating. So let's say let's do it this way. So I have I'll call this right hand. Of course, why not? Right hand. Hey, right hand is equal to the length of the string minus 1. Length of the string s minus 1. Left hand is equal to 0. The left hand has to be 0. We want to start from 0. Great. So yeah, so let's say for that's too quick. Now, how do we go through the swap? Where we obviously need a loop, right? But then what kind of loop do we need? Do we want to look at indexes? No, we don't want to look at indexes. We already know that, we have an item here, so there's no need for index looping. What we need is a condition to keep the loop running so that we can make our swaps each time, right? Is this big enough? I don't think so. Shift Alt was Alt Shift plus. Yeah, so this is big enough. That this is the highest I can zoom in. So that condition will be while you know while our right hand, right right hand is less than the left hand, because at some point they will clash, right? Less than the left hand, sorry, right? We want to swap, right? We want to take item at right hand and swap it to the item at left hand. So how do we do that? We take the string here, right? We put left hand, left hand. We always start from left hand, right hand, s at right hand is equal to s at right hand, then s at left hand, right? So this will just switch the values, right? We are not assigning values, we are switching values here. Although it's a form of assignment, but this assignment is not any, it does, we don't lose values, right? The values remain there, but their indexes just is just changed. So what do we do for the left hand? We increment the left hand, right? We'll do left hand plus equal 1 and right hand minus equal 1, right? And I think that's it. This is the solution. This is all we need. So every time, well, as long as the right hand is left than the is less than the left hand, we are good to go, right? Wait, if it is, well, yeah, it would have increased. Yeah, so this is it. I believe so. Let's go. Let's go here. Let's come to this place. Let's do this. Oh, what's this? Where's my list? I'm confused. I'm thirsty right now. I've been talking for the past 1 hour 30 minutes. I'm really thirsty. I want to drink water. Let's run this. No way. Wait, what? Hold on. What just happened? Don't be too confident, guys. Hello. I swapped the values. Huh? Right hand, left hand. This is strange. Hold on. What happened? As long as left hand is by increasing left hand, right? Okay, let's imagine the case where so we have 0. How did this move to this place? Hold on. This is an infinite loop, sorry. I don't think. Why is, am I doing something wrong? I said left hand. Hold on. I think I need to run a solution. Um, hello, right? So, I'm dehydrated right now. Solution stood down. Solution is equal to solution. We create an instance of this solution and let's just print this solution, right? Reverse the string, put this here, run this. Yeah, we are not returning anything, but I want to log the value of this each time we print 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 s. Ouch. Print s. So how are we going to do that? You see, oh my god. Ah, well, while right hand is superior to this, right? Christ. Yes, this is it. This is the answer. Oh, damn. It's left hand that is. Yeah, that's it. Christ. Oh my god, I finished at the right time. Yes. Yes! This is the best solution. Best. Best of the best solution. How is this beating everybody? 99.99. Oh, sorry. How am I increasing my score? 93.90. 93.55% and then 83.04%. Yeah. Almost. All right. That's it for today. I'm off to go and drink some water. Yeah, I'm really tired right now. This stream wouldn't have been. I mean, I did all my best to do it today. I'm not going to miss a single day. Hopefully, I would come here and stream. All right, we're improving problem solving skills and so on. Yeah, eyes on the prize. I really enjoyed this. Honestly, it's been amazing. I want to give a speech. Um, yeah, I think my friend Emmanuel might be watching this, but I'm not sure. Any day he gets to watch this, I've mentioned his name here. All right.